This is 10.2 trig review. So we used sine, cosine, and tangent a couple days ago to find missing side lengths, but now we're going to work on missing angles. So we're going to investigate this relationship a little bit more. So what I want you to do is just kind of think, back in geometry, you did learn when you took geometry in like secondary 1, secondary 2, you're supposed to learn about right triangles, and you learned about side, 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 angle, angle, angle. You learned about these relationships and a few of the properties. So I just want you to kind of think back to those and get your brain back in this stuff. But one thing that is really important that you remember, and you're supposed to learn this in secondary 1 and secondary 2, is corresponding angles are congruent. So if I tell you that, hey, this triangle right here is similar to this triangle right here, that means that if we could match up their angles, the corresponding, right, so those marks that we put, if you remember these marks, those are all the same angles. They're the exact same. Even though one triangle looks bigger than the other, they are the exact same angle measurements. And the sides are not the same, obviously, but they are proportional. All right, so what I suggest you do is I suggest you pause this and try 2 through 3 and then come back. So I think you'll learn a lot more if you look at it, try it, and then watch it. So pause, work it, come back. All right, so number 2, find each of the following missing parts of the triangle, show your work, and explain how you found the answer. So I'm going to put a star right here and a star right here because we have an angle measurement and we have theta, so that's the angle we're focusing on. So if you notice, we have opposite and we have hypotenuse. So I'm going to use sine. So sine of 19.5 degrees is going to be opposite over hypotenuse. And I'm going to multiply both sides by 9, put it in my calculator, and I'm going to get that A is 3. All right? So if I just put in sine of 19.5, right? Just put it in. Where is it? Sine of 19.5. And then hit math. It won't let me, right? But 3/9 is 1/3. So I did round 19.5 a little. That's why it won't change to that. But basically, sine of theta is is 1/3. Okay. All right. So using that idea, if we look over here, we actually have not just a similar triangle, but we have the exact same triangle, right? So 3/9, 3/9, they're the same. So that means that theta has to be 19.5 degrees because they are similar triangles. Okay, so look at this one. What is the length of W? Oh, okay, so we have the same relationship because of the angle 19.5, but it looks like we stopped this side a little bit shorter, right? So that would be about the one that we're looking at down here. It's only 6 long instead of 9. So if we solve that one using our skills from last time, we multiply by 6, multiply by 6. Let's do that. Sine of 19.5 times 6. We get 2 when we round, right? All right, W equals 2. Okay, so 6/2, that means that this is 19.5. Okay, so if we have that relationship, the angle has to be 9.5. And you notice 2 divided by 6 simplifies down to 1/3. So here we had 3/9, here we have 2/6, but they both simplify down to 1/3, and they both have that same angle measurement. So corresponding angles are congruent, sides are proportional. So use the triangle at the right to answer the following questions. what is the sine ratio for theta? So sine theta will be opposite over hypotenuse, which simplifies down to 1/3. Okay? All right. Okay, we already know about this relationship. 1/3, 1/3. We know what theta is, right? Theta is 19.5. The ratio of the sides will be the same as the triangles above, so the angles must be congruent, 19.5 degrees. Okay, so awesome. Cool relationship there. Let's look at a few more relationships. Okay, I don't know what that is doing there. Sorry. It wasn't copying on my version. Hopefully not on yours either. Okay, so we're going to learn about special angles here. So this is kind of jumping back and forth. But we're going to solve each of the following triangles. So solve means find all side lengths and angle measurements. So this one's pretty good. We have this is 30, we have this is 90, so we only need one more angle, which is going to be 60 degrees, right? Because a triangle, the inside angles will always add up to 180. And so here we are with 90 in one corner and then 30 in the other. So 90 plus 30 minus 180 leaves us with 60, right? Now there's a couple ways that we could find, we have these two sides already, there's a couple ways we could find this other side. We could use the Pythagorean theorem. Right, so let's do that real quick. We have 16 plus b squared equals 64. We minus 16 minus 16. B squared equals, so minus that we get 8, right? Then so 48. If we take the square root of 48. Now, notice it said have it in reduced radical form. So 48, if you think about that, we have to simplify that a little bit. 48, what could we divide that by? Just kind of think of that. 48, how are we going to simplify this? Well, we can have 16, and you might not have gone this direction, but 16 times 3. 16 is 4 times 4, means a 4 gets to leave, a 3 has to stay. So b equals 4 root 3. Okay. The reason I use the Pythagorean theorem is because it said to leave it in reduced radical form. And if I would have set up sine of 30 degrees equals, oh, not sine. Why would I want to do sine, right? If I would have done tangent of 30 degrees, then I could do opposite over adjacent. I could solve for that, but it would, remember, tangent of 30 will always give me a decimal. I mean, whenever I put the trig ratios in, it gives me a decimal. So that wouldn't have been nice to get that radical, okay? But if you do it in your calculator, you'll find that you get the exact same answer. Okay, now this one here, we have 30 degrees here, right? Filling that in. So if we look at this, we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. So a squared equals a squared plus 36 equals 144 minus 36 minus 36. 144 minus 36 leaves us with 108. Take the square root of both sides. Now, 108, what does that divide by? I think it does divide by 4. Yep. So 108 will give me 4 and 27. That'll give me 2 times 2, 3 times 9, which is 3 times 3. So 2 gets to leave, a 3 gets to leave. 2 times 3 is 6. 6 root 3. All right. and then this has to be 60 degrees. And then if I do a squared plus b squared, that'll give me c squared. So I'm going to put that in my calculator real quick. $256. If you take the square root of 256, it'll give you 16. All right, so we solved all those. Now let's fill this in. So if we look at our short leg, on the first one it was 4. The short leg on the middle one was 6. Short leg on the last one was 8. Long leg was 4 root 3, 6 root 3, 8 root 3. And then the hypotenuse was 8, 12, 16. So I just want you to look at this relationship. So these are all different triangles, but they're similar, right? So they all have the same congruent angles. So they were all 30 degrees, 60 degrees, 90 degrees. And the sides, if you notice, there's definitely some patterns here that you can see. So notice those. And the pattern that I see is that the hypotenuse is double the short leg, and the long leg is the short times root 3, right? So 4 times root 3, 6 times root 3, 8 times root 3. So, nice. All right. Let's take a look at this one. So if this is 45 degrees, and we have these symbols here, meaning that if that's 6, that is also 6. So if we think about it, if this triangle, and by triangle I mean angle, if this angle is producing 6 degrees, this angle also is producing 6 units, inches, whatever, right? So those angles produce the same thing. That means that between those we have 90, and this is also 90. So we have a 45, 45, 90. 6, 6. Now I'm going to use the Pythagorean theorem. 6 squared plus 6 squared equals 36 plus 36. Well, let's do that really quick. 36 plus 36 gives me 2, okay, 1, 2, 3, 4, 5, 6, 7, 72. Okay? Square root is 72. 72, that has lots of numbers that go into it. 8 times 9 pops into my head. So 9 times 8, that'll be 3 times 3, 2 times 2 times 2. So a 3 will come out, a 2 will come out. 3 times 2 is 6, and 2 will stay. All right. So we already have all the angles, and if that angle is producing 10, then this angle will also produce 10. We could also use, if we wanted to, sine of 45 degrees, to find this. But I'm going to use the Pythagorean theorem. So 10 squared plus 10 squared equals 200. I'm going to have to take the square root because a squared plus b squared equals c squared. So 200 is c squared. So that's why I have to take the square root. So 200, if I simplify that radical, will be 2 times 100, which is 10 times 10. So 10 leaves, 2 stays. So let's look at this. First triangle, leg is 6, leg is 6, leg is 10, leg is 10. And then hypotenuse is 6 root 2 and 10 root 2. What do you notice about the angles and sides of the triangle? Well, the angles are all 45, 45, 90. The legs are always equal. And the hypotenuse is equal to root 2 times the leg. Awesome. Okay, so important ideas in these two activities that we just did, and then we'll do some examples. So similar triangles. This is what we just learned. If two triangles are similar, their sides are proportional. And corresponding angles are congruent. This allows us to figure out angles from side ratios. Okay, so what am I saying right there? Well, what I'm saying is, I didn't give you, if we go back to whatever page this is, I didn't give you the exact same triangle, right? I mean, I did in A, and I did in A and B, and I did in C and D, but in A, C, and 3, they were all different, right? 5, 15, 6, 2, 9, 3. But because they were all made from an angle of 19.5, they all had the same ratio. And by understanding that fact, we can then use, as I'll show you in a second, we can then use inverse trig ratios functions to find angles, okay? So these are used to find angle measurements. From sides. Okay, so what you'll do is you'll set up the equation, then you'll solve for the missing angle. Let me give you an example of this real quick. So if I say sine of theta equals 1/3, now you already know it's supposed to be 19.5 when we round, okay? But theta is trapped, it's the input of sine. So what we're going to do is we're going to apply the inverse of sine here, which will cancel that out, leaving us with theta. But what you do to one side, you have to do to the other. So the angle will be inverse sine of 1/3. So let's take a look at that. All right. So if you look at sine, find the sine button. Right above it, you see sine inverse. So I'm going to hit second sine, and I'm going to put 1/3 in there. And you notice I get 19.5. All right. So theta equals 19.5 degrees. Awesome. Okay, so what does this mean to us? Well, so that's the y. Now let's see, what are you going to do with this? So if we take a look here, we have to find this angle measurement. This is our focus point. So if that's our focus point, we have, whoa, what am I doing, right? We have opposite. It's pointing right to the opposite. Boom, 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 boom. Right? That angle, if we go from that angle to line up with the opposite, the 90 degrees always points to the hypotenuse. It technically is touching the angle. That's why it's called adjacent, but that's the leftover one. Okay? So there's lots of ways we could find this. So you kind of just pick which one you want to use. So sine of theta, that question mark, I'm going to call it theta, will be opposite over hypotenuse. I could have used cosine if I wanted to. Cosine would be adjacent, cosine of theta will be adjacent over hypotenuse. Or I could have used tangent. Tangent of theta will be, what, opposite over adjacent. Now, it doesn't matter which one you choose in this point because you had all of the leg lengths, at all of them. Now, that's still not our goal, though. Like, that doesn't really give us much. We still need to apply the inverse. So if I do the inverse, what you do to one side, you do to the other, it'll cancel out here and leave us with theta, and then the rest we'll just need to put into our calculator. And you could have done this with any, okay? It didn't have to be this one. So if I do that real quick, second sine of 24 divided by 26, I get 67.38 degrees. So that right there, 67.38 degrees. Now I could have done it with cosine, right? All I would have had to do is apply the inverse. That cancels that out. Apply the inverse of 10 over 26. Second cosine of 10 divided by 26. As you notice, gives you the exact same thing, right? Oops, wrong button. Okay, so there you have it. All right, so let's look at a few more. Let's look at 13. All right, so here is our focal point. Our job is to find the missing side lengths. So now we have an angle, we've got to find the missing side lengths. So if you remember, it's 45 degrees, which means this is 45 degrees, which means this is 4, and this is also 4. Now if you remember, this is a little bit longer. It was 4 root 2, if you remember. So, I mean, we don't even need to put that in our calculator. We can figure that one if we just look back at our notes, okay? All right, let's look at another one down here. All right, so here's our focus. This time we can't do anything we want. We can't do sine, cosine, or tangent because all we have is opposite and hypotenuse. We have to use sine on that one. Take a look at this one. This is our focus. We only have adjacent and hypotenuse. So you won't always be able to use whatever sine, cosine, tangent, whatever trig ratio you want. This one I'm going to have to use adjacent, hypotenuse, right? I'm going to have to use cosine of theta, gives me 16 over 46. And so I'll apply the inverse. Apply the inverse. That cancels out. Theta equals 16 over 46. The inverse, cosine inverse, 16 over 46. Oops, wrong thing. And we get 69.65 degrees. So that equals 69.65 degrees. Awesome. All right, so hopefully you tried a few of those there. You can go back. This is your homework. Take a look at it, and then I will go over it. You'll see the other video. All right, have a good one.